Okay, practice problem number 1, where we're going to go 1 through 4. Practice problem number 1 is the iron going from 300K to 1100K, where we have our delta H is equal to specific heat times delta T. Our change in temperature is 300 Kelvin to 1100 Kelvin. Specific heat is 25.1 kilojoules per mole. So you just put in your CP, 25.1 kilojoules per mole. Put in your delta T, 1100 minus 300, because 1100 is our end, our final temperature. 300 is the beginning, or our initial temperature. So 1100 minus 300 gives you 800. 25.1 times 800 will give you 20,080 kilojoules per mole. For number 2, same equation, same setup, but now we're looking at ice that's warming from negative 10.8 degrees Celsius to negative 0.4 degrees Celsius. The specific heat for ice is in 37.4 kilojoules per mole. Put in your numbers, specific heat, and then delta T, and our negative 0.4 minus negative 10.8 gives us 10.2, comes out to 381 kilojoules per mole. Number 3, calculate the mole enthalpy change when a piece of aluminum that is temperature of 293.15 Kelvin is cooled to temperature of 277.15 Kelvin. The CP for aluminum is 24.2. The temperature change will be 277, which is the final, because it's being cooled down. So 277.15 minus 293, which was the initial, and that will be 16 Kelvin. Put those numbers in your calculator and it gets 387.2 kilojoules per mole. Number 4, calculate the delta H of NaCl when it is heated from 0 to 100. The molar enthalpy for, or specific heat for NaCl is 50.5. So delta H is 50.5, which 100 minus 0 times 100 gives you 5,050 kilojoules per mole. Questions 5 through 7, pretty much the same thing. Number 5 is calculate the delta H when tungsten is heated by 450 Kelvin. So now in this case, they don't give you a final temperature and initial temperature. They just give you how much it's heated by. So that is your delta T. It's saying that it is heated by 450, or the temperature rose by 450 Kelvin. So you put in your CP for tungsten, which is that W, 24.2 kilojoules per mole per Kelvin times 450 gives you 10,890 kilojoules per mole. Number 6, kind of the same thing, where they give you mercury and it says cooled by 250. So if it's cooled by, that means it's going to have a negative delta negative delta T of 250 Kelvin. And your your CP, 27.8, and then times negative 250, delta H is equal to negative 6,950 kilojoules per mole. Number 7, we're going to have lead, and it is cooled from 400 to 75. You have your CP, which is 26.4, and the difference between those, 75 minus 400, is negative 325 Kelvin. Gives you negative 8,580 kilojoules per mole. Pop quiz coming soon.